Welcome to my channel for comprehensive tutorials on fundamental principles to complex problems. I'll cover it all. Feel free to share, subscribe for more contents. Thank you. Hello everyone. This is exercise 17E, rather long awaited 17E that you can find on page 335 in the book that you can see on the screen. Now I'm taking straight to question number 1. This is further sequences, and this is the extended part of the topic 17, 17 chapter. In here, first of all, in the first question, it says 12, 36, and 144, and you need to find the next term in each of these three exponential sequences. Exponential is a different kind of sequence in which we need to see the relation between them. Now, as you can see, that 12 times 3 is giving us a 36, and 36 times 4 is giving us a 144. So definitely next is going to be 5. So 144 times 5 is going to give us 432. Next is a sequence in which 13, 39, 117, and 351. Let's see what the relation is. 13 times 3 is giving us 39. 39 times 3 is giving us 117, and 117 times 3 is giving us a 351. So that means 351 times 3 is going to give us a 1053. Next is part C, in which you can see 2 times 5 is a 10, 10 times 5 is a 50, 5 times 50 times 5 is 250. That means next 250 is going to be multiplied by 5, which is going to give you 1250. Moving on to the next one, as you can see, 20 divided by 24 is going to give us 1.6, I guess. Let's see. 24 divided by 20 is going to give us a 1.2. And the relation that is building up is 28 or 24 times 1.2 is going to give us 28.8. So every number, every term is multiplying by 1.2. So that means 34.56 when multiplied by 1.2, it's going to give us 41.47 and 2. Now comes question number E. In here you can see 4 is multiplied by 20 to give you an 80. So the relation that you can see, it's an exponential. So 80 times 20 is going to be 1600. That means this number also has to be multiplied by 20 to give you a 64 00 and 00, 640,000. Next comes another sequence that we have. In here you can see every time it is dividing by 2, dividing by 2. So next is going to be a 15. Next term is going to be a 15th term. Next, when you see question number G, it is 1000 is 1000 when you divide by 200. So it's give you 5. So that means this number is dividing by 5. And when 200 is divided by 5, you get 40. And 40 divided by 8 is also going to give you an 8. That means 8 when divided by 5, it's going to give you 1.6 as an answer. So next term is going to be 1.6. Let's see with the next one. As you can see, it is the relation between them is 108 when divided by 162 is going to give you 0.66. So this is continued, and when 48 is multiplied by 0.6, let's see, it's going to give you 32 is the number that you can get. Please be reminded that you have to put as many zeros, as many 6 after 0 point in the calculator to get exact 32, or else you'll get 31.99 something. Moving on to question number 2. Now here are the nth term of some sequences. In each sequence, find the first term T1 and the fourth term T4. So the term rule is saying 6 to the power n. That means you need to write in your notebook something like this, T1 and T4. So in here, first term is going to be 1. That means first term is a 6, and 6 to the power 4, when it comes to 6 to the power 4, is going to give you 1296. So this is going to be the answer for part A. When it comes to question number B, let's bring these guys a little down here so that we can solve each question in this way. Now comes second one in here, T1 and T4. So T1 is going to be 8 times 2 to the power 1. That is going to give us 16. And when 8 times 2 to the power 4, which is a 16, so that means 8 times 16 is going to give us 128. When it comes to the next part of it, I'll bring these guys over here with little space. Now in here it is 5 times 3 to the power n. That means T1 is going to be 5 times 3 to the power 1, and T4 is going to be 5 3 times 3 power 4. So this is going to give us a 15, and the next one is going to give us a 405. Please be reminded to put 3 to the power 4 as 81. 5 times 81 is going to give you 405. In here, term 1 and term 4, this is going to give us a 40 times 0.51, and in here 40 times 0.5 power 4, and the first one is going to give you as 20. The answer for this one is going to be a 20, and 0.5 power 4 is going to give you 40 times 0.0625. So finally, you will get as 2.5 as an answer, which is going to be the term 4. Next is moving on to E part, which is 81 times 2 over 3, and the power is 1. So it's going to be same. That means 8 times 2 over 3. So this is going to be cancelled using a different pen. It's going to be giving us a 27 times 2, which is going to be 54. Now this is term 1 we are talking about. So this is term 1 is a 54. And when it comes to term 4, it's going to be 81 times 2 over 3 with the power of 4. That means 81 is going to be multiplied by 2 power 4 and 3 power 4. That means 81 times 16, and 3 to the power 4 is going to give us 3 to the power 4 is going to give us an 81. So these 81 and 81 get cancelled, and 16 is going to be your answer for term 4. Now moving on to the next question, which is question number 3. 3 says work out the nth term of each of these sequences and write it in the form of t term n. Now the relation that I can see here, that 50 times 2 is 100, 100 times 2 is a 200, 200 times 2 is a 400, and 400 times 2 is an 800. Now in here, I can see I will definitely write 2 to the power n first. Now 2 to the power n, when I'm talking about term 1, so actually it is 2 to the power 1, right? Now 2 to the power 1 is a 2. So what should I do with the 2 to make it a 50? So definitely I'm going to multiply it by 25. So this is going to be a term rule or nth term for this sequence. Now let's try if my term rule is right or wrong. Let's see. For example, I'm talking about first, second, third, fourth. Fourth term is a 400. Now test it. Now 25 times 2 to the power 4. Let's see what it gives. 25 times 16 is giving us a 400. That means the term rule is correct. Now moving on to part B. The relation I can see is 3 times 2 is a 6, 6 times 2 is a 12, 12 times 2 is a 24, and 24 times 2 is a 48. So as soon as I see 2, so I will write 2 to the power n. And this 2 to the power n is actually a 1. What should I do with the 1 to make it a 3? I will multiply it by 1.5. So this is going to be the term rule for this sequence. And make sure to test any relation that you are making with this. Now comes next part. Now in here, 6 times 3 is an 18, 18 times 3 is a 54, and 54 times 3 is giving us a 162. So that means as soon as I see this 3, I will write 3 to the power n. Now this is actually a 3n or 3 to the power 1. 3. 3 is what to do with the 3 to make it a 6. I'll multiply by 2. So 2 to the power 2 times 3 to the power n is going to be the term rule, and make sure to test what you write here. Now comes part D. In here, I can see that 120 becomes 60 and 60 becomes 30 and 30 becomes 50. So the relation I can see is a half. Okay, 120 times 0 0.5 is 60, 0 0.5, 60 times 0 0.5 is giving us a 30, and 30 times 0 0.5 is giving us a 15. So that means 0.5 n is going to the first part. Now this is 120. This is 1. So now with what I should multiply this to get a 120? I will multiply by 240 to give me a term rule for this sequence. Now comes the next one. Now I can see 45 times 0 0.9 is giving us 40.5. And how to get 0.9? It's simple. When 40.5 is divided by 45, you will get 0.9. 0.9 n. Now this is 0.9. What should I do with 0.9 to make it a 45? Definitely I will multiply by 50. So this is the term rule for this sequence. Next is part F. In here, as you can see, 80 times 1.25 is giving us 100. 100 times 1.25 is giving us a 125. So that means 1.25 n is going to be the first one, and when multiplied by 64 is going to give us the term rule for this sequence. Now going on to question number 4. This is an interesting question. So they're asking you to find out the next two terms, which is 3 and 4. So it says Serena has 5,000 saving. She expects her saving to increase by 40% each year. So let's see what can be done for this. In here, as you can see, when 7,000 divided by 5, it's going to give you 1.4. 1.4. And as soon as I get this number, I know very well that the term or the expression that comes out is going to be 1.4 n. Okay, and mind it, this is 0. Okay, this 0 tells you that on the first one the term is 0. So anything power 0 is a 1. So when 1 is multiplied by 5,000, it's going to give you a 5,000. Okay, so the term or the expression for this sequence is going to be 5,000 times 1.4 n. Now with this, using this term rule, we are going to find out the next two terms. Now when 5,000 is multiplied by 1.4 to the power of 3, that is going to give you a value which is 1.4 to the power of 3, which is 2.744. When multiplied by 5,000, it's going to give you 13,720. So the value over here is going to be 13,720. And for the fourth term, we are going to use the same term rule, which is 5,000 times 1.4 to the power of 4. So 1 times 1.4 to the power of 4 is going to give you 3.8, 3.8416. When multiplied by 5,000 is going to give you 19208. 19208 is going to be over here. 19208 is the value that is going to come in the fourth term. Now moving on to the next question. In this question says find the nth term of each of this sequence. As you know, the difference between these two is a 3. Between these two is a 5. Difference between these two is a 7. And these two is a 9. Go for the second difference. This is called as first difference. Now this is a 2, and over here you can see it's a 2, and over here it's also a 2. So when second difference is a same, so for example, this is called as n, as we are done with the previous topics. This is called as n square. So n square is actually a 1 when the power is 2. So this is going to be giving you a 1. So what to do with 1 to make it a 2? So you add 1. That means n square plus 1 is going to be the term rule. For moving on to the next part, which is B, 7 plus 3 is a 10, plus 5 is a 15, plus 7 is a 22, and plus 9 is a 31. Second difference is 2. When the second difference is common, so eventually we write n square. Now this is a 1. What to do with this 1 to make it 7? We add 6 to it. So this is going to be the term rule. Moving on to the next. As you can see, the difference is 2, and difference is 4, difference is 6, and difference is 8. Going for the second difference, which is 2, 2, and 2. So this tells us it's a n square, and this is a 1. What to do with 1 to make it 0? We, as you can see, this is the first term, second term, third term. If you write a minus 1, that's not going to work because it's going to give you a different value. Let's try with 1. And if I am looking for this one, I'm just trying this one, okay? So n square minus 1 if we see. So that means it is a 1, 2, 3, 4, 5, fifth term. So n to the power 5 minus 1. That means 5 to the power 5 minus 1, 25, minus 1 is a 24. So we are getting a wrong answer. So we cancel this and we go for something different, which is n square minus n. Now let's see if this term rule works for us or not. Now in here, for example, fourth term we are talking about. So 4 square minus 4. That means 16 minus 4 is going to give 16 minus 4 is going to give us a 12. So that means our fourth term, which is 12, okay, that's same way we can check for the 5 also. So 5 square minus 5, that means 25, minus 5, which is a 20. That means our term rule is working well. So that means n square minus n is the term rule for nth term. As you can see in this sequence, the difference between the first one is a 9, then second difference is 15, then comes 21, and between 75 and 48 the difference is 27. So this line is called as a first difference. Now going for second difference, in here you can see the difference is 6, difference over here is also 6, and difference over here is also 6. So as soon as you see this, it is a quadratic sequence. Okay. Now in here, this is a 1. What to do with this 1 to make it a 3? We multiply by 3 as this is exponential. And for example, if I go for, if it is 1, if I want to make it a 3, I will add this 2. So this is also can be the term rule, but let's see if it is right or wrong. Now this is actually a 1. 1 plus 2 is a 3. First term is fine. Now when it comes to n square plus, for example, if I write this term I'm talking about, or if I take this term, which is third term, that means 3 square plus 2 is 9 plus 2, which is 11, which is a wrong. So that means this term rule is not going to work. So what is the next option we have? Now in here, I said it is n square is the first thing that you should write. Now from here, it is actually a 1. What to do with this 1 to make it a 3? Other option is to go for the multiplying by 3. Now let's see if it is the third term is working or not. So that means 3 and 3 square, which is a 9, and 3 times 9 is a 27, which is fine. So this is going to be the term rule for this sequence. Moving on to the next one. The difference between the first two is 9. Second one is a 15, as you can see here. And the third one is 21. And next to this is a difference of 27. Moving on for finding out the second difference. This is the first difference. You must write once you're working in the notebook. Difference is 6 between these two. Difference is also 6. And this is also a difference of 6, which is second difference. Now, you know very well it is n square. Now, n square is actually a 1. Okay. So always when you see this 9, so the root of 9 is a 3. So now this is a 3. So what to do with the 3 to make it a 1? We definitely are going to minus 2 from 3 to make it a 1. So this is going to be the term rule for this sequence. Let's try to find out the third term, which is 25. Let's see if this gives us a 25. That means 3 times 3 square minus 2. That means 3 times 9 is a 27, and 27 minus 2 is giving us a 25, which is fine. This nth term rule is perfect. Moving on to the next question, which is giving us 4, 14, 30, 52, and 80. Difference between 14 and 4 is a 10, of course. Between these two is a 16. Between 52 and 30 is going to be 22. And the last one is 28. As you can see here, the difference is 6. Difference here also 6. And when the common difference is 6, that means first thing you do is n square. Now, as you know very well, n square is a 1. Okay. So now multiply by 3, and this is a 3 now. What to do with this 3 to make it a 4? Definitely, we have many options. For example, the 3 minus 1 is, or 3 plus 1 is also an option. We can go for this. Another option is 3n square minus n. Let's see which one is giving us a third term like this one. Now, if I try it with this one, that means 3 square plus 1. That means 3 times 9 plus 1. That means 27 plus 1 is a 28. Now, which is wrong. We should get a 30. Now go for the second option of term rule. Here I'm saying 3 and 3 square minus 3, which is the n term. Now in here this means 9 minus 3. That means 27 minus 3 actually should be a plus n. So 27 plus 3 is going to give us a 30. So this term rule is working fine, and this is going to be the term rule for this sequence. Moving on to the next question, which is question number 6. As you can see, these are the first four triangular numbers 1, 3, 6, and 10. And let's see what the difference between them I just bring this guy a little down. Now difference between these two is a 2, difference between these two is a 3, difference between these two is a 4. So next term is going to be 15. 10 plus 5 is a 15. And then it's going to be next is 21. So these are the two numbers that are missing for the first next two triangle numbers, which is 15 and 21. Now comes find the nth term of the quadratic sequence. Now first of all find the difference, bringing it a little down. So the first difference between these two is a 4, between these two is a 6, between these two is an 8, next is 10, that means 12. Okay, over here when we go, so the difference is 2, and when we go for this, that means it's telling us as soon as we see this, I will write n square, and when we subtract, add the nth term to this, we are going to get it. Now let's see, we find out 1 2 3 4 fifth term. So fifth term is 5 square plus 5, that means 25, plus 5 is going to give us a 30. That means this term rule is fine, and this is your answer for this question. As it can be seen, it says use your answer from part B to find an expression for the nth triangular number. And what are triangular number? Triangular numbers are 1, 3, 6, 10. Let's see. How do we get 1, 3, 6, and 10? Now, the term rule that we have is n square plus n. Okay. Now, how do we get these numbers? Now, for example, n square is a 1. Okay. So 1 plus 1 is a 2. So how to make a 2 is you multiply this by half. That means you multiply the whole thing by 0.5. Or I better write the other way around. I am going to write this way: 0.5 n square plus n. That's how it's going to give you a triangular number. Let's try for the third term. Let's suppose this term we have no idea how much it is. Let's see, we find out. Now it is 0.5 times 3 square plus 3. That means 0.5, 9 plus 3. That means 0.5 times 12. So half of 12 is going to be a 6, which is the right answer for this number. So expression for the nth triangular number is this one. Now it says in the next question, work out 20th triangular number. That means 0.5, 20 square plus 20. That means 0.5. This is going to be giving you a 400 and 20. That means half of 420 is going to be 210. So this is going to be the answer for part D. Now in the next question it says show that 1275 is a triangular number. That means 0.5 n square plus n is equals to 1275. That means we are going to try numbers starting from 10. Let's see if it is 0.5, 10 square plus 10. Is this equal to 1275? Let's see. It is 0.5. 10 square is 100 plus 10. So half of 110 is not 1275. So 10 is not the right number. Let's go for 20 and we will reduce if it is more than 20. Now 20 square plus 20 is going to be half of 400 plus 20. That means half of 420 is 210, which is not the right answer. 210. Now go for 30. 0.5, 30 square plus 30. So this is going to give us 900 plus 30. So half of 930 is not 1275. 0.75 we are looking for. Go for 40, 0.5, 40 square plus 40. Is this giving you 1275? Let's see. Half of 40 square is going to be 1600. 1600 plus 40. And half of 1640 is not 1275. Okay. So it's going to be 820 something. 820, which is not the right answer. Let's go for 50. 0.5, 50 square plus 50. So it's going to give us 0.5, 2500 plus 25. That means half of 2550 is 1275, which is the right answer. That means 50th shape is going to give us 1275. That means it is proved that 1275 is a triangular number. Moving on to the next question, which is question number 7. Now in here, find the nth term of each of these sequences and write in the form of term n. Now the difference of 0 and 7 is going to be, of course, it is going to be a 7. Then comes a 19. Next is a 37. And the next one is 61. Now let's see how much is the difference between these numbers. Difference between these numbers is 12, 18, and a 24. This is called as a first difference. This is called as second difference. And let's see if it is a common difference. Yes, common difference is 6. That means here we understand it's a cubic sequence. So we write n cube first. Now, as you see this, you just write 0, 7, 26, and 63, and 124. So just below this, if you write numbers as 1, because a cube of 1 is 1, cube of 2 is 8, cube of 3 is 27, and cube of 4 is 64, cube of 5 is 125. You must notice that there is 1 missing out of it. So what should we do with 1 to make it a 0? We will subtract 1. Okay, and subtract 8 makes 7. Subtract 1 from 27 gives you 26. That means it has to be n cube minus 1 is the term rule for this question. Now moving on to the next question, which is part B. I am going to take this part B over here. I guess I keep these questions a little down, and this has to be here. Okay, so this is fine here. Now in question number B, you can see the difference between these numbers is, first is 7, then comes 19, then next is 37, and next is 43. By the way, this number is 175, not 157 in the book. Okay, so second, this is called as first difference. Then comes a second difference, which is going to be from here. I should change the pen now. Second difference between these numbers is going to be 12, and then 18, and then the next difference is 24. This is called as second difference. Now comes common difference, which is 6. As soon as we see this, we know very well it's a cubic sequence, so we write n cube. Okay, now from n cube, this is a 1 actually. Okay, what should we do with 1 to make it a 51? We will definitely add 50 to it. So this is going to be our nth term for this sequence. As you can see in the next question, we begin with finding out the difference, which is called as a first difference. So first difference, as you can see, it is 8. Next is a 20. Next is the difference of 38, And last comes the difference of 62. As you can see, the second difference we go for is between these numbers. First difference is a 12, second is 18, and the next one is a 24. This is called as a second difference. We go for the third sequence, which is 6. As you can see here, it's a fixed or a common difference. So as soon as you see common difference, we write n cube. Now we have this n cube is should be considered as 1. So what are the possibilities that we can make it a 2? How can we make 1 a 2? By adding 1. Okay, let's see and try if this is a right method of finding out 30 as a third term. That means 3 cube plus 1, which is giving you 9 plus 1. That means this term rule is not good, not correct. Now go for other option. This is n cube and plus n. That means you will be adding the term number. So let's begin and find out if it is correct or not. That means 3 cube plus 3. Let's see. This is 27 and plus 3 is giving us a 30. And there is a correction here. It is 27 plus 1. It was giving us a 28, which is a wrong answer for third term. Right answer for third term is this one. That means this is a correct term rule for question number C. Next is 414. That means the difference is 10. Next difference is a 22. Next difference is a 40. And the next difference is a 64. Finding out the second difference between these four numbers. First difference is a 12. Second difference is 18. And the next difference is 24. Going for the last difference as a common difference is the first difference. This is the second difference. And the common difference is 6. Once we reach to the third level, that means we are talking about n cube. Now, this is n cube, okay? N cube means 1. What should we do with 1 to make it a 4? We can add 3, okay? Let's see if it is giving us a second term. That means n cube means 1 plus 3. If it is 2, that means 2 cube plus 3. 2 cube plus 3 means 8 plus 3, which is 11, and we are not getting a 14, okay? Now let's begin with another trial. N cube plus 3n. Let's see if this gives us a correct answer for term 2. That means 2 cube plus 3 times 2. That means it's giving you 8 plus 6, which is 14, which is the right answer. That means this term rule should be considered as correct answer for this question, and this one is wrong. Let's move on to question number 8, which is over here. It says in here are some triangles made from oranges. You might be seeing this in blue color, but in the textbook, if you have, you will see this in orange color. So if these oranges are put into 4 layers, they make a tetrahedron. Now, we need to find the number of oranges in tetrahedron for with 4 layers. That means 1 over 6 is multiplied by 4, and 4 plus 1 and 4 plus 2. That means 1 over 6 times 4 times 5 and times 6. That means this 6 is going to be cancelled with this 6, and 4 times 5 is going to give you a 20 as an answer for this part of the question. Then comes check this expression gives the correct answer with n4. That means 4 times 5 times 6 divided by 6 is giving us a 20. Means 4 times 5 is a 20. 20 times 6 is 120. And 120 divided by 6 is going to give us a 20 as an answer for this part of the question. That means this expression is correct. Now, a shopkeeper has 100 oranges. He wants to display them in a tetrahedron shape. Work out the largest number of layers he can have. Now he has 100. Now let's see if we put 1 over 6, 7, and what is the term rule? 7 plus 1 and 7 plus 2. Let's see what it does it give you. 1 over 6 times 7 times 8 times 9. So this gives us 7 8 times 56 times 9 divided by 6. And if I further reduce this, so 3 times 2 is a 6, 3 times 3 is a 9. That means we have 56 times 3 divided by 2. And if we further reduce this by 2, that means 2 times 1 is a 2, and 2 times 2 is a 4, 2 times 8 is 16. That means 28 times 3, 3 times 8 is 24, 6, 7, 84. So 84 oranges are going to be used, the largest number of layers. So 84 layers can be made out of 84 100 oranges, because if you go further, it's going to go more than 100. Now let's see to find out the answer for part D. Let's see what question number D says. D says show how to use the formula to add the first 20 triangular numbers. That means 20 layers is going to multiply by 21 and 22 divided by 6. So it gives us 1540 oranges. Now comes question number 9, which is the last question of this exercise. Now it says 6, 16, 30, 48, and 70. The nth term of the sequence is given by an plus bn square, where a and b are the numbers. By looking at the first term, show that a plus b equals 6. That means over here, if you see, it says an plus bn square equals first term, which is a 6. That means if I put a plus b, and in place of n, I will write 1 here, and I will write 1 square, and equals 6. That means a plus b equals 6, which is proved. Now a plus b equals 6. Now use the second term to find out another equation involving a and b. Now look at second equation, which is uh, second term, which is 16. Now second, remember this 2, second term we are talking about. That means an plus bn square. That means in place of n, we are going to write a 2. That means a plus b equals 16. But in place of n, I'm going to write a 2 here. Okay. And 2 square here. So this is going to give us a 2a plus 4b equals 16. This is the second term. Use this to find the involving a and b. This is the answer for part B. 2a plus 4b equals 16. Now in part C, it says solve the equation from part A and B simultaneously to find the nth term of the sequence. Let's begin. First, I'm going to write 2a plus 4b. 2a plus 4b equals 16. And the first equation is a plus b equals 6. Find out the value of a and b. You know very well, we are going to equalize a. That means we multiply this whole thing by 2 and this also by 2. That means 2a plus 4b equals 16. And second one is going to be 2a plus 2b equals 12. Now We make a straight line and do the subtraction part. Subtraction, subtraction, and 12 becomes a minus. So these two are going to be cancelled. 4 minus 2 is going to give us a 2b equals 4. That means the value of b equals 2. When the value of b is 2, and in the first equation you are saying a plus b equals 6, that means the value of b is already given as 2. So 6, that means a equals 6 minus 2. So the value of a is going to be a 4. This is the answer for this last question, last part. Now going back to where we began, this was the exercise 17E, which was long awaited, and here I am to upload this video. See you soon.